In this lesson, we're going to figure out how we can create a quadratic function given 3 points. So what we want to do is find an equation in standard form of the parabola that passes through the following points. So we know that it must pass through 1, -2, 2, -4, and 3, -4. So we want to create a quadratic function, and it must be in standard form. So the first thing we have to do is remember what standard form is. So standard form is when we have y equals ax squared plus bx plus c. So we want to create a quadratic that looks like this. So what we need to do is remember how we used systems of equations. So what we're going to do here is we're going to create 3 different equations based off of the 3 points that were given. So the first point is 1, -2. So what I'm going to do is I'm going to plug in that point into my standard form equation. So into the equation here. So I'm just going to block that for you. Okay, so we want to plug in 1 for x and -2 for y. So we're going to have -2 equals a times 1 squared plus b times 1 plus c. So if we actually try to clean this up a little bit, 1 squared is 1, 1 times a is a, b times 1 is b, and then c. We're going to do the same thing with the second point here. So here's the second point of 2, -4. So our second equation, again, we're just going to plug in 2 for x and -4 for y. So we have -4 is equal to a times 2 squared plus b times 2 plus c. And again, let's clean that up a little bit. So 2 squared is going to give me 4. So I have 4a. b times 2 is going to give me 2b. And then c is going to just be c. And then we're going to do that one more time for our third point. So we're going to use that point 3, -4, and we're going to plug in 3 for x and -4 for y. So -4 is equal to a times 3 squared plus b times 3 plus c. And then again, let's clean that up. So 3 squared is going to give me 9. So I have 9a. b times 3 is 3b. And then plus c. So all I'm going to do right now is just rewrite these equations in the corner just to have them in a way that we're used to seeing. So when we look at systems of equations, let me just fix that there. We're used to seeing the equation on one side and then equaling the number on the right-hand side. So I'm going to make the first equation just a plus b plus c is equal to -2. My second equation, just going to do 4a plus 2b plus c is equal to -4. And then my third equation is going to be 9a plus 3b plus c is equal to -4. So now we have 3 equations. So if we think back to our lesson on systems of 3 variables, we're just going to follow the same exact thing now. So we want to look at all 3 equations and we want to see which variable would be easiest to eliminate in all 3 of them. So in this case, when you're creating your own quadratic, the c's are going to be the easiest to get rid of because the c will never have a number in front of it. It will always just be c since there's no x attached to the c. So you could get rid of the a's or the b's if you would like to, but it's going to be easier to get rid of the c's. So just like before, we're going to use 2 at a time and we're going to cancel out one of the variables. So I'm going to start by doing equation 1 and equation 2. So equation 1, I have a plus b plus c is equal to -2. And then what I'm going to do with equation 2 is, because my c, they're both positive c's, I need to multiply the entire second equation by a -1, so that way I can just add it. You can also just subtract everything, which is basically what we're doing. So I'm going to make this -4a minus 2b minus c equals +4. So all I've done is taken equation 2 and I've multiplied it by -1. So now what I'm going to do is just go ahead and add this straight down. So I'm going to add a and -4a. So that's going to give me -3a. I have b minus 2b, so that's going to be -b. The c's are going to cancel out. And then I have -2 plus 4, so that's going to give me 2. Okay, so this is like that equation 4 that we're creating. Okay, so I'm just going to circle that, and we're going to come back to it. So I've already used 1 and 2. I need to use 3. So it doesn't matter if you use 1 and 3 or 2 and 3. I'm going to use 2 and 3. So I'm going to go over here. So I'm going to use equation 2. So 4a plus 2b plus c equals -4. And I'm going to use 3. And again, what I'm going to do is multiply the entire third equation by a -1 so I can change all my signs. So I'm going to get -9a minus 3b minus c equals +4. And then, because I have the c's that are opposite signs, I can just go ahead and add this straight down. So 4a minus 9a is going to be -5a. 2b minus 3b is going to be -b. The c's are going to cancel out, and then -4 plus 4 is going to give me 0. So now this is equation 5. So I'm just going to circle that one. So now what we're going to do is we're going to use our 2 circled equations, and we're going to try to eliminate a variable there. So if I look at them, they both have b's, and they're both -b's. So what I'm going to do is try to get rid of the b's, and I'm going to multiply one of them by a negative. Okay, it does not matter which one. So let's take the -3a minus b equals 2, and we're going to stack it with this one, but what I'm going to do is I'm going to multiply this one by -1, so times -1. So we get 5a plus b equals 0. So I'm going to add these because my b's are opposite signs. So I'm going to get that 2a, these are going to cancel out, is equal to 2. So if I divide by 2, I'm going to get that a is equal to 1. So once I have one of my variables, what I'm going to do is go back up to one of my circled equations. So I could pick either of the 2 circled equations, and I'm going to plug in 1 for a. So what I'm going to do is go to my -5a minus b equals 0 equation, and I'm going to plug in, negative 5 times 1 minus b equals 0. So I get -5 minus b equals 0. So I end up getting that b is equal to -5. So I have a. I'm just going to box this for right now. I have b. And now to find c, I'm going to go back to any of the original 3 problems, and I'm going to plug in my a and b and solve for c. So I'm going to use equation 1, and I'm going to plug in my a, which is 1, plus my b, so that's -5, plus my c, and that's equal to -2. So I get -4 plus c equals -2. So I end up with c is equal to 2. And I'm going to box that. Okay, so now what I've figured out is what a, b, and c all are. So if I know a, b, and c, what I'm going to do as my last step, how I'm going to finish this problem, is I need to write it like a quadratic. So I'm going to take that standard form, that y equals ax squared plus bx plus c, and I'm going to plug in the a, the b, and the c. So I have y equals, my a is 1, so it's going to be 1x squared, plus bx, so my b is -5, so I'm going to have -5x, and then my c is 2, so I have plus 2. Okay, so this equation right here, this quadratic that I'm boxing like crazy, is your quadratic function that passes through those 3 points. Okay, so we're going to look at one more just to see if we understand. Okay, so if you need another example, you can watch this. If you don't, then you can just try the homework problem. So again, we have y equals ax squared plus bx plus c. That's our goal. That's what we're trying to get it to be. So I'm going to have my first equation based off of my first point. So I'm going to plug in 1 for y and 1 for x. So this is going to give me a times 1 squared plus b times 1 plus c. So I get 1 equals a plus b plus c. My second equation, I'm going to use my second point. So again, I'll plug in my x and y. So negative 3 equals a times negative 1 squared plus b times negative 1 plus c. So I'll get negative 3 equals a minus b plus c. And then for my third equation, I'm going to use my third point. So I'll plug in 1 for y, and then I'll plug in negative 3 for x. So plus b times negative 3 plus c. Cleaning it up a little bit, we get 9a minus 3b plus c. So my three equations that I'm working with are going to be a plus b plus c is equal to 1. I'm also going to be using a minus b plus c is equal to negative 3. And then finally, I'm going to be using my third equation, which is 9a minus 3b plus c equals 1. So we want to cancel out one variable in all of them. Okay, you can choose which one you would like. Again, I think that the c's will be the easiest. So similar to the last problem, I'm going to start with 1 and 2. So a plus b plus c equals 1. And then I'm going to take equation 2 and I'm going to multiply it by a negative. So I have negative a plus b minus c is equal to positive 3. So now I'm going to go ahead and add this straight down. So my a's are going to cancel out. B plus b is going to give me 2b. My c's are also going to cancel out, and that's equal to 4. Okay, so it's okay if things cancel out more than one at a time. Okay, so now right away I can solve for b. I can divide both sides by 2, and I get that b is equal to 2. So what I can do now is either do 2 and 3 or 1 and 3 and cancel out my c's and then plug b in, or I can try to plug b into 2 and 3 from here and then solve that. Okay, so I'm just going to follow the same pattern that we were doing before, so it's not as confusing. So I'm going to take equation 2, okay, which is a minus b plus c equals negative 3, and I'm going to use equation 3, but I'm going to multiply equation 3 by negative 1. So I have negative 9a plus 3b minus c equals negative 1. I'm going to add this straight down. So I'm trying to cancel out the c's again. If I wanted to cancel out the a's, I could because they also canceled out here. But I'm going to focus on the c. So a minus 9a is going to give me negative 8a. Negative b plus 3b is going to give me 2b. My c's will cancel. And then negative 3 and negative 1 is going to give me negative 4. So I can then take the b that I solved for over here. This b is equal to 2. And I'm going to just plug that into here. So I'm going to say negative 8a plus 2 times 2 equals negative 4. So I'm just going to go ahead and solve this. So negative 8a plus 4 equals negative 4. So negative 8a, if I subtract 4, I get negative 8. Divide by negative 8. So a is equal to 1. So now I have A and I have B. So now I can just go to my original problems and solve for C. So I'm going to use equation 1, and I'm going to use my A, which is 1. I have plus my B, so plus 2, plus C equals 1. So I get 3 plus C equals 1. So C is equal to negative 2. So now that I have my A, my B, and my C, I'm going to go ahead and plug this in to my standard form. So I end up getting y equals, so I have ax squared, so a is 1, so 1x squared, plus bx, and b is 2, so plus 2x, and then my c is negative 2. So then here is my quadratic function that goes through those 3 points. Now you're going to try this problem where you need to write a quadratic function that passes through the given 3 points.